Hello, for today's lesson we're going to be using our graphing calculators to graph quadratic functions. So if you have it, please take it out, otherwise just follow along and write down the table of values and plot as we go. Okay, if you do have your calculator, I do encourage you to type these as we go through. Okay, so let's look at number one. So if we're going to graph and label a quadratic function, what I'm going to do is I'm going to type this equation into y1 in my calculator. So press the y equals button. Okay. Type in the function that you see that we're going to graph into y1. Okay, so for example number 1a, it's going to look like x, and you hit the square button, but you could also hit the caret button if you want to as well. X squared minus 4x minus 6. Okay. Now what we're going to do is we're going to look at a table of values to plot it, because if you were to hit graph, you would see what it should look like, but you won't as easily see the points you're going to be plotting. And I want you to be very specific with the points that you're plotting. So if you go to second graph, which is second table, finds the table values, you can find out that this function, f of x, has the following value. So I'm going to write, since I don't really have as much room here, I'm going to split the table up into a couple of columns so I can plot as many points as I can. Since this graph goes from negative 12 to positive 12, both for x and for y, I'm going to plot all the points that I can on those intervals. So noticing if I scroll up and down in my table, negative 2 comma positive 6 is my first point that I can plot. So I'm going to copy down the table from negative 2, and if I scroll down in my table, I'll notice that I can go all the way up to positive 6. Okay, so I'm going to plot all those points. So my table gives me negative 2, gives me positive 6, negative 1 has me plot negative 1, 0 has me plot negative 6, then negative 9, negative 10, negative 9, and you should see some kind of symmetry here. These graphs will have some kind of pattern, and we'll have a maximum, we'll have a minimum, so we'll go to a number and then go back down or go back up. So let's plot this graph as many points as I can. So I'm going to plot the first point, negative 2 comma 6. Negative 1 comma negative 1 is the next point. 0 comma negative 6. And then we have negative 9, negative 10. And notice it is symmetric with itself, so it's easy to plot the remaining of the parabola. Just make sure you're not skipping any x values, as is often the case. Now when you're drawing your curve, do not make it look like this. Okay, it cannot have a sharp turn. It must look as smooth as possible. So it's not going to go through negative 3. So just make sure, at least on this graph, so it will eventually, but I'm going to draw my graph as careful as I can, and I'm going to zoom in so I can draw a really nice graph. And then once you get down to that point, you're going to stop, and you're going to turn around at that point. You're not going to go through it very sharply, you're just going to turn around at it and go right up like this. Make sure you put the arrowheads on both ends, and you have your function, f of x. I'm going to label it on the end, on the right. Okay. Typically you label things on the right side. So go ahead and let's graph function g of x. So we're going to go back to the calculator's y equals function. We're going to, in place of what we had before, we're going to type in negative 2x squared minus 20x minus 90. You're going to get your table of values, and you're going to plot the points. So getting the table of values, scrolling up and down in the list, I notice that negative 10 gives me negative 10, and negative 11 will give me something that's really small. That's off the graph. So I'm going to start negative 10, negative 10. So I'm going to write a table of values. I'll start with negative 10. Scrolling through my graph, looks like it can go up to negative 4. So I'm going to plot as many points as I can. So let's copy down the table. And again, you'll see that there's some nice symmetry here. Okay, I'm going to zoom into the graph, and you don't see me zooming, but I'm zooming, so I can draw some nice graphs. And I'm going to plot these points. So negative 10, negative 10. There's a point right there. Negative 9, 0. There's a point right there. Negative 8, comma 6, right here. Negative 7, comma 8, there. And then fill out the rest of the parabola to negative 4, negative 10. Okay? And then just carefully draw in the parabola by connecting those points. Okay? Make sure the top of that parabola is nice and curved. You don't want to have something that's very sharp and jagged. Make sure you're going through the points as best as you can. I'm going to label this one as g of x. Okay, pause the video now, draw any more of the parabola you need to before going on to number 2. Okay, so I want you to right now pause the video and type in the graph for number 2 just to get the table, then we'll plot it together. So just get the table. So pause the video to get the table. Okay, so getting the table of values, you'll notice that we have some decimal values. And that's okay. That's going to happen sometimes. I'm going to write a horizontal table this time just so I can fit a little bit nicer. So I'm going to still plot as many points as I can on the graph. It goes from negative 12 to positive 12. So noticing scrolling through the table at negative 4, comma 10 is going to be the first point that I can plot. But notice for negative 3 I have 2.5. So that's going to be a decimal point, but we can still plot that. Negative 2, negative 2. Negative 1, 3.5. 0, negative 2. 1, 2.5. And 2, comma 10. So this, again, some symmetry here, which is expected. Okay, I'm going to plot these points. So the first one's easy to plot, negative 4, comma 10. That's the set of integer points. Now the next one, which is negative 3, comma positive 2.5. So what I'm going to do is I'm going to go over to negative 3, I'm going to go up 1, 2, and a half. That's where I'm going to plot my point. 2.5. Plot the next one, negative 2, negative 2. Right here. And that should be a negative 3.5, right? Okay, hopefully you guys picked up on that. Let me erase that. Okay, so negative 3.5 is going to be associated with x equals negative 1. Go back to the pen. Here we go. There we go. All right, negative 3.5. And then it goes back up for the corresponding points. Oops, too far over. There we go. And then 2, comma 10. Okay, so here's that graph. We're going to connect the points as clearly as we can, making it as nice of a curve as possible. Make sure it's curved at that vertex point. And of course your graph's going to look much better than mine. But here we go. There's function f of x. There's that parabola. Okay, so you pause the video now. You can practice letter B. See what you get. Okay, practicing letter B. You'll notice you have a lot of points that you can plot in this one. Okay, so if I use the table, that's a horizontal table. Notice the smallest one I can plot is 4, and the largest one I can plot is 12. So 4, 5, 6, 7, 8, 9, 10, 11, 12. And I go from 12 to 5 to 0 to negative 3 to negative 4 to negative 3 to 0 to 5 to 12. Okay, and plotting this, you have 4, comma 12, 5, comma 5. Then I have 6, comma 0, 7 comma negative 3, then negative 4, negative 3, 0, 5, and 12. Okay. And I'm going to use my stylus pen to draw as nice of a quadratic function as I can. Again, making sure it's curved towards that vertex point, that minimum in this graph. And I'm going to label this one as g of x. Okay. Alright, pause the video, write down anything you need to before going on to the next ones. Okay, so what we're going to look at now is a system of equations graphically, solving them graphically. We're going to have one line, one linear function, and one parabola, one quadratic function. Should be clear which one's the quadratic, which one's the line. The quadratic will have an x squared, the line will not have an x squared. So what we're going to do is we're going to graph both of these onto the same grid. Wherever they intersect is going to be my solution set. We really have three different scenarios here. We can either have a line and a parabola intersects twice, so we have two solutions. We might have a line and a parabola intersects only one time, which gives me one solution. And we may actually have a parabola and a line that don't intersect at all. Then we'd have no solutions. Okay, so we're going to see what's happening in this graph. To do that, what we're going to do is we're going to get the table of values for the parabola. So the parabola is going to go here. So type that in your calculator right now into y1 and see what the table of values is going to be. Okay, so it looks like in my calculator I can start at -5 and go up to 3 on the x's. So -5, -4, -3, -2, -1, 0, 1, 2, and 3. And I'm going to copy the y column, which is -7, 0, 5, 8, 9, 8, 5, 0, -7. Okay, so there is my parabola. So I'm going to go ahead and plot that. Start with -5, -7. Just right there, I believe. Yes, good. -5, -7, -4, 0. Then it goes up to 5, 8, 9, 8, back down to 5, down to 0, and down to -7. I'm going to carefully draw this as best as I can. Okay. It's going to take some time for me to graph it because I'm graphing it zoomed in, which means I have to stop and move around to get to the next part of the graph. Alright, and there's my parabola. What I'm going to do now is I'm going to graph the line, the linear function. And you pay attention to what kind of form it's in. This is in slope-intercept form, so I can easily identify the slope up to over to the right one. And the y-intercept is going to be 3. So I'm going to start at the y-intercept, which is at 3. I'm going to plot as many points as I can. And when I hit my parabola, I'm going to go ahead and circle that point because I know it's going to be one of my solutions. So, plot as many points as you can. Ah, no. Don't move. There you go. Making the points is making me select things instead of making the points. Alright, and then going to the left, down to right, down to left 1, down to left 1. There's an intersection point. Okay, and I'm going to carefully draw my line. Even though we already know our solutions, we still have to draw in the line to indicate the second function. We're doing this graphically. So we have two intersection points, which means we have two solutions. And solutions to these are always going to be written as a pair of coordinates, a coordinate pair. Doesn't matter which order you put them in. I'm going to go from left to right. So the first solution looks like to me at -5, -7. That's this one down here. The second solution is at +1, +5. And there are my solutions to this system of equations graphically. Pause the video, write down anything you need to before moving on. Okay, now this last example, number 4, The parabola is the first equation, and the line is the second one. The parabola is written in standard form, so I got to type that in my calculator. Now I'm noticing the 1/4 in front of the x squared. Just like that example in number 2 in the notes, we're going to have some decimal points. And I still want to plot as many points as I can, because the graphs might actually intersect at those decimal points. So let's type that in our calculator, the parabola, into y1. Right. Pause the video to write the table if you need to. Okay, so I'm going to write my xy table. This looks like a fairly lengthy table. You might have to break this up into 2 separate tables to make sure you have enough room to draw it in, because there's a lot of points we can plot. It looks like from -2 all the way up to +12. -2 to +12. Okay, -2 is comma 11 is a point. Then we have 7.25, 4, 1.25, -1, -2.75. Then we have -4, -4.75, -5, and it looks like it's starting to repeat the pattern. So -4.75 going backwards, -4, -2.75, -1, +1.25, and 4. And it can keep going in the y's, but we can't plot past 12 on the x-axis, so we're going to stop right there. 13 would be at 7.25, and 14 would be at 11, but we can't plot those points. So let's plot them as carefully as we can. -2, comma 11. It's up here. Okay. -2, 7.25. So let's set 7.25 is 7 1/4. So go up 7 and go out 1/4. Okay. Make sure you're very careful about plotting those points. The next one's going to be at 4. 1 1/4. Oops, that's just 1/4. 1 1/4 is right here. -1. -2 3/4. But notice that it's just above the line, just like it was before. So -3/4 is just because it's below the x-axis. Should be in the still. See how this is just above the line, and this is just above the line. Don't circle those just yet, but that's indicating it's in the right spot. Okay. So -2 3/4. Then we have -4, -4 3/4, and then -5. Okay, so it looks like it's bottoming out right there. Let's come back up. Can you fill out the rest of the points by looking at the other side of the graph? It goes up to 4. This one's going to be a nice one to plot, because it's nice and it's less steep of a parabola, but careful going through all these points. Okay, there's my parabola. Now I got to graph my line. Now notice the line is in point slope form, which means I'm going to start with the point that it intercepts, that it goes through. So -4 comma -8 is going to be my starting point, and I'm going to use a slope of 3/4. Okay. So -8, -4, -8 is right here. There is my starting point. So I'm going to use up 3/4 to plot the next point. Okay. Up 3/4. So notice we're not plotting a point on the parabola, but notice that it will go through this point right here. Okay, which is a 1/4 point. Okay, so I'm going to circle it right now just so I don't forget about it. Even though I didn't plot on the parabola, it will still go through it, so it will be a solution. Up 3/4. And up 3/4, and that last one right there is the last point on the line that will intercept the parabola. So drawing in my line, I actually could plot one more point on here. Okay, but I have all the points that I need. So notice the solutions. And notice the solutions could always be found within our table of values. Right? They're going to be found in the table of values for the parabola. And it looks like that first solution is at 3, negative 2.75. And the last solution is at 12, 4. Okay, and there's your solution to the system of equations. Alright, pause the video now, write down anything you need to before working on the assignment. Okay, for the remainder of class, I want you to start working on assignment 5.4, and I want you to finish it over the break. Okay, and I will see you when you return. Have a good break.